I've spent the last 13 and a half years living in the best city in the entire world, and if you were in my last talk, you already know where that is. That is, of course, Brno, Czech Republic. And that is why this talk is in English and not in Czech. On these slides, you'll find a QR code. This goes to the website where the slides are. It also leads to my website if you're interested. So what is Flatcar Linux? Flatcar Linux is a special purpose operating system. It is focused exclusively on running containers. Those can be orchestrated containers, like you might have in, say, a Kubernetes cluster, where Flatcar is just one worker node in a whole cluster of nodes running containers that the cluster wants. It could be unorchestrated containers, like you might have with a Docker Compose, Podman pods, or that you might just start with your container runtime of choice. Flatcar is a CNCF project. That means that it is an open source, vendor-neutral, community-driven project that is part of the CNCF, the Cloud Native Computing Foundation. These are the folks who bring us Kubernetes. They own all of the trademarks and the assets. But I bring this up because Flatcar has a very long history before it joined CNCF. Flatcar started as something called Container Linux by a company called CoreOS. CoreOS was purchased by Red Hat, and they took the code and their Project Atomic, and they mashed them together, and they now make all of the CoreOSs in Enterprise Linux: Fedora CoreOS, Red Hat RHEL CoreOS, and CentOS Stream CoreOS. But they changed the code. So another company named Kinvolk started, and they picked up the original Container Linux code, renamed it Flatcar, and kept it rolling. Microsoft bought Kinvolk about 5 years ago, and then Microsoft donated the operating system to CNCF. So what is special purpose versus general purpose here, and what's the difference? So in a general purpose operating system, you think about features. In a special purpose operating system, you think about functionality, and that's how we define Flatcar. So in a general purpose OS, when you sit down to install it, you decide what shell you want, whether you want glibc or Musil, do you want systemd or not, what desktop do you want? You choose all of those features. And on day 2, those choices continue. You have to decide if you want to update to the next release and watch all of your underlying dependencies change, whether you want to go to the latest version and pull something back to the code you're running, whether you want to add a third-party repository for access to more tools or potentially things that replace stuff you already have. When you look at a special purpose OS, though, we define at the functionality layer, not the feature layer. Flatcar's functionality promise to you is, we will run your containers. And there's a functional contract there between your container workload and the container runtime you've chosen, the kernel where it's appropriately involved, and anything you might bubble up from the host like a GPU. We think about Flatcar like a light switch. Light switches provide the functionality of turn light on, turn light off. You don't care if it's a European-style square rocker switch or an American toggle switch. The light goes on, the light goes off. If you need that specificity, you should probably use a general purpose Linux, or you should bundle that dependency in with your application and ship it in your container. Another difference is that Flatcar is provisioned, it is not installed. Now, I've been speaking English a long time, and I won't lie, I didn't really understand the difference between these two words until about a year ago, maybe a year and a half. To me, they meant the same thing. But what it means is this: when you install a Linux, at the moment you assemble that system, you make the choices of what it's like. You choose those features. And typically, installation has 2, possibly even 3 rounds that it goes through. There's an interactive install that something kicks off, even if it's like a kickstart. Then there's usually a post-install where you'll walk through the system again with something like Ansible. And then oftentimes, there's the super secret third part where a human being actually logs into the machine, mucks around with it for a few minutes, and then says, okay, it's ready for production. But when you provision a machine, you do it differently. You write a specification for what the machine should do, exactly what it should look like and what workloads it should run. You give that specification to a provisioner, which will get an operating system, smash the two together and config it, and first boot it. And the machine you are delivered is running the workload and in production. You can use provisioners in public cloud, virtualization, everywhere. But the point is you wrote just a specification. For Flatcar, that specification is written in a YAML called butane. And I'm getting a little ahead of myself, I apologize. Our specification is written in a YAML called butane. We believe very strongly, though, in no boilerplate and sensible defaults. So you can provision a Flatcar machine without a specification, and you will get a functioning machine. It is fit for a purpose, maybe not your purpose, but it will run. So you only have to override or tune the things you actually care about in that specification to meet your specific need. The second pass, or even the third pass of installation, are anti-patterns when you do provisioning. Another big difference with Flatcar and a lot of Linuxes is it's immutable. And immutable actually means a lot of things. The first is there's no configuration drift. If you configure a machine in Flatcar, it is configured exactly one time at first boot and at provisioning, same sequence. It never gets reconfigured. So if you run two provisions with the same provisioning specification, you get two identical machines and they stay identical forever. Another meaning of immutability is that the file system is actually read-only. /USR cannot be modified after it's put together. So this means that you can't make a mistake, and generally attackers will have a hard problem too. The OS is provisioned as an entire read-only partition. This leads to another form of immutability, and that is around dependencies. Dependencies do not change except when you update the operating system. And I'll talk about updates a little later. But the way this works out is this. If you have two machines that report that they are running the same version of Flatcar, they are actually identical in all ways. This laptop's running Fedora 43. That laptop might be running Fedora 43. This laptop got DNF updated about 2.5 weeks ago. That one may have been DNF updated this morning. They're both going to tell you they're Fedora 43, but they actually have different software versions on them. Onesie-twosie on laptops, it may not matter, but at scale and in production, these kinds of drift changes matter, and Flatcar is immutable there. So I'm going to try and do a demo right quick to show you some of this. Let's see if this works. Where am I? Woohoo! Okay. So this is what the butane YAML files look like. There's two things that look like boilerplate at the top, and that's just saying we're butane for Flatcar, and we're using this version of butane. I've set an SSH key for the user so that I can log in. I've also set a host name and a static IP using systemd so that I can find the machine. I've also added a web page, which I just included. I can show it to you. It's basic HTML because I'm going to be running a web server. And there's a systemd service here at the bottom that will start the Docker container that's the web server. And I turned off the update engines because irony would be if the machine rebooted underneath me during this demo. You have to transpile the butane into JSON, demo1.bu, out to demo1.ign. I want to show you that's not magic either. This is what YAML looks like when you remove all the new lines. The only thing that's odd here is the base 64 blob in the middle. That's the HTML page. Butane, for butane reasons, decided that you get to see the plain text of the system, the systemd unit. Yeah, that happens. I wrote a little shell script so I don't have to remember to type all of these SSH options to get into it. No magic there. I'm in the machine. I forgot to show you that the web server's there, but I hope you believe me. There's a web server running. The really important thing that I wanted to show you is this. Root cannot touch the file system. But root knows how to do that, right? We'll just remount it. Root cannot remount the file system. It is read-only. You are not going to get to play that game. I didn't say it out loud in the earlier slide, but The file system is not just immutable, it is actually DM verity guaranteed to you, which I just showed you the wrong thing. Let's try that again. How about that? Look at that. That's a hash. Okay, it's DM verity guaranteed to you. What this means, the short version as I understand it, there's a whole sequence of hashes through this file system. The kernel can tell if so much as one bit of something it's about to run has changed. And if the file system has been modified, bad disk, malware, doesn't matter what, it will kernel panic and refuse to run instead. Another layer of security for you. The other piece that I've showed you here is user A and user B. These are the update partitions. I'm going to talk about those in just a second. The names are arbitrary. We're currently booted into A, and I know that because the priority is 1. It's the higher priority, and it's successful. The other one's never been booted on this demo machine. So how do updates work? You have an A and a B partition. One is active, one is inactive. There's an update daemon that pays attention for updates from the infrastructure, grabs the update, verifies it, writes it to the inactive partition. This is an atomic operation, so if it fails at any point, it just starts over again. You're not using this partition, nobody cares. Once it's successfully written, it flags the machine for reboot. That's how you upgrade. You reboot the system. There's a reboot daemon that applies a reboot policy of your choice. You could do the one that I used to do by accident, which is the default, reboot immediately upon receiving an update. And then when you put a monitoring system in, you're like, what did I do? Because you never noticed it was rebooting before. But you can also set up maintenance windows. It can also query the cluster for permission to reboot, be put on a schedule, or just turn it off and do it manually, whatever makes you happy. When you reboot, it switches the active partition, it boots the new updated partition, and it does a check to make sure everything's green. You can also include workload checks for that. If any of these checks fail, it goes something bad happened, switches back to the old partition, reboots, and your workload keeps going. That gives you time to go deal with what's going on without having a 4-alarm fire because all of your workload went down. It's also atomically clean. You can just roll back. We produce a bunch of different versions of Flatcar. I am not going to read you this slide. They are all targeting specific kinds of users and their needs. What I want you to take away from this slide is on the alpha line. Every single one of these is fully tested. We actually fully test every PR that affects the disk. We don't do docs and things like that because you don't want to waste resources. And by fully tested, I don't just mean unit tests. We have over 100 end-to-end real-world scenarios that we run, everything from boot one node and make it sure it works, to build this cluster and verify all of these things. And every single thing, including our nightlies, go through these tests. We believe every one of these are good for you to run. But as a project, we recommend stable. Not because it's better, but because it has one attribute that's special. Stable is a beta that has been promoted up, and the betas have been run by our users in their clusters over time. So our end-to-end tests, if you think about it, are vertical, but our users put beta nodes in service and they run them horizontally under load. Exposes a different kind of thing. We keep an eye on beta feedback. When it's good, we'll promote the beta to stable. Another cool thing is that we can test the entire operating system against itself. Every single component that ships gets shipped or tested against itself. Going back to my Fedora 43 example, Fedora 43 was tested when it GA'd. Used to work with those folks. They're great. They do a great job. But it's hard to keep testing when you're getting new stuff in the operating system every single day. And so they fall behind or they're not able to keep up with that testing. It's also very hard in a general purpose operating system to test every possible thing that you could install with every other possible thing. Flatcar makes a functionality promise. The features are ours to manage. So we tested all of them against each other. Now you may be wondering, how do you add things to the host that belong on the host when you can't write to the host? And the answer to that is another demo. Let us get out of this machine. hopefully we are going to there. Yes. So the answer to this is to type correctly. The answer to this is also something called systemd-sysext extensions. So I want to show those to you in practice. This is another machine, same SSH key, same networking, different IP address. I am putting two files that Podman needs, a policy file and a search file, because it gets a little wonky if it doesn't have its configs, but I'm not putting Podman in. I want you to notice that. And then down here, I am actually nulling out Docker and Containerd. Docker and Containerd are system extensions that we ship and we bake into the image because most of our users use them. I'm taking them out. And then I turned off updates again. You've seen my go before. All right. There is no Docker on this machine. Oh, okay. Sudo bang bang. There is no Docker at all on this machine. It's not turned off. It's not masked. It ain't there. My container runtime of choice is Podman, which is also sadly not there. But Podman is available as a system extension. So what is a system extension? It is an overlay FS that comes over the file system that is also read-only and immutable, and it delivers more tools. You would download the system extension normally from the repository when you're doing the build and the provisioning step, but you can actually add them live. Because I don't trust conference Wi-Fi, I am simulating the download by copying it into place. And now I'm going to refresh to do the overlay. And we have Podman. But what's really cool, in my opinion, is Podman is where it should be in user bin. Everything just looks like a file system to you, but it's still all read-only. It's still all DM Verity. You can actually get rid of it. Again, I'm deleting it, and I'm going to refresh again. And Podman is gone. Bash actually remembers where it is because Bash has a long memory, but it's really gone. So Flatcar will run anywhere you want to run a system. We're in all of the tier 1 providers, my employer Azure, as well as AWS, GCP, all the tier 2s that you can probably think of, and many of the tier 3s. It runs on all the virtualization you probably ever care about. It will run on bare metal. I didn't do this demo on it. That would have been a little too hard because there's no desktop. But it will be. This machine has run it in the past. You can use iPixie. You can actually directly install it from a flash. You can orchestrate all of the build out and whatnot with Terraform and all of those fancy sysops tools or DevOps tools that I don't personally use, but they're there. They're amazing. You should use them. Go to flatcar.org, please. It's the greatest place in the world. It's the best website on the internet after the Brno City website. And there you'll find our docs. You'll find information about the project. You will also find that we have a matrix channel where we chat. If Slack is your jam, we're in the CNCF Slack. We do most of our asynchronous work in GitHub on GitHub issues. And we have a bunch of live meetings every month. You'll see them up here in this list. The cool thing is they're all EU-friendly times because almost all the maintainers are EU folks. Ken Volk was a German company. There you go. Thank you very much. I strongly encourage you, if you have Camus or any virtualization on your laptop, try it today before the after party. Do you have any questions? Questions I can answer.
Thank you for the talk. I'm already using Fedora Koreos. It's also another.
Sorry?
I'm also using Fedora Koreos. It's another immutable distribution, but it's from Red Hat. Can you compare the Koreos to Flatcar Linux?
I can give a bit of a comparison between CoreOS and Flatcar, but I'm not an expert in CoreOS. When I was in Fedora land, I ran Fedora IoT, which is another OS tree-based immutable, but it doesn't use Ignition and it doesn't have a cluster use case. CoreOS uses Butane just like Flatcar does. It runs containers. I think by default ships with Podman because Red Hat. Otherwise, it's a solid OS. They have channels and everything else. The big difference from what I understand is I believe their channels update based on time gates, and we use user feedback. I know they can halt the time gates, but I think there are, in fact, time gates that drive their updates. The other big difference between the two is they use OS tree, and we use AB update partitions. And I'm not trying to speak ill of CoreOS at all when I say this, but OS tree has an interesting piece of functionality that is a non-starter for certain use cases. So OS tree is kind of like Git for your operating system. You can effectively Git check out a new hash and you get a whole new OS, and you can Git revert back to the operating system. It's more complex than that, but that's the gist of it. But OS tree has this functionality. They can run system extensions, but before they did, they use this thing where you can effectively open up the read-only partition and tell it to DNF install an extra RPM or two. And then it will carry that RPM onward as an overlay in the install every time you git pull OS tree update a new OS. For some use cases, the fact that you can, on the system, break the immutability of the system and create a change that is persistent is a violation of the use case. Flatcar does not have that functionality. But I want to be very clear about something. Flatcar's systemd-system extensions can be made mutable. It's not something that we do, but the systemd-system extension standard in systemd does have a mutability case. And there's some argument about whether that's okay or not in some of these extreme situations. But that's the core difference. I guess the other big difference is Thilo and the folks are amazing in Flatcar, and Dusty and the folks are amazing in Fedora CoreOS. You just got to decide whose name you want to say.
Okay, thank you very much.
Thank you. Other questions? Dalshiotaski? Thank you. I learned it on a Shalina.
Hi. You said that you can run Flatcar on anything. How is the support on embedded systems, for example?
I'm sorry? Support.
How is Flatcar supported on embedded systems? You said that Flatcar can run on anything. Can we run it on
I may have
Raspberry
been
Pis?
a little overly generous. I actually don't know the specific hardware support myself, but I'm sure it's something you can find out on the website. And if you can't, please ask in our matrix or ping me directly and I'll get you an answer. But I don't know the answer to that. Flatcar is one of the many special purpose operating systems that are out there. The Yocto group, which tends to work in embedded space, is another special purpose OS. And there's like a cadre of us that talk periodically at places like FOSDEM. So we may not all fully overlap. I can't make that promise. Other questions? For those of you who didn't see my earlier talk, I'll offer this brief sales pitch, which is I don't just use Flatcar for my projects because I now work with this team. I actually use it in part because much like CoreOS and Fedora IoT, I wanted something that had an appliance feel to it. I gave a talk earlier today where I use Flatcar because it's updating itself. It knows how to not fall over on me, and I can go back to drinking coffee and not thinking about it.
I just wanted to say that I loved how confident presentation that was. Like, you were like...
I really appreciate that because I've practiced. This is all practice and fear hiding under a hoodie. Yes, please.
I have a question regarding the testing, because you said that you test everything with everything. Does it mean that you and other general purpose systems cannot do that because there's too many features? Does it mean that you have less features? Or does it mean that you just take a lot of time to do it once?
So in our case, it is, the definition of features I was using was essentially pieces of software that you can install. So in that sense, yes, we have less software because we choose software to deliver the promise of your container workload running. Your workload is taking a dependency on your container runtime, some level of kernel because of how containers work, and then anything you bubble up like a GPU. You're not taking a dependency on which version of bin-utils we're running, whether there's a Python interpreter on the machine or not, whether SSH is enabled. Those are things below the line of contract. And so we get to pick, for example, what SSHD we want to use, whether Python's on the system, those kinds of things, because you're not relying on that. So that's why we can test all of these features against each other. There's a finite list.
And the extensions are also included in this, or is this like...
I was scared you were going to ask me that. I actually need to go look, because I'm actually not sure what the level of test coverage for the core extensions is. I'm sure they are tested, but I don't know if they are fully tested through all the scenarios. So like Docker probably gets more testing than say Podman does, even though they're both core extensions. There's also, and I forgot to mention it, there's a systemd system extensions bakery, we call it, where the community builds extensions. Things like Tailscale are in that, and I'm sure that there's not a Tailscale test in those 100 tests. But they're tested differently because they're tested on the bakery side.
Thank you.
You're welcome. It's weird having a rail here. Other questions?
Okay, I guess I thank a lot of Brian for his presentation.
Thank you very much.